Hi everyone, I'm Cheryl. In this problem, we're going to take a look at the graph of f prime, and we're going to use just the graph to get some information about the graph of f double prime and also the graph of the original function f. We're not going to be taking any derivatives, so it's just going to be based on the graphical information. Okay, we're going to start with the second derivative. Now, what do I know about the second derivative? Well, by looking at the first derivative, I notice that right here at x equals -4, I have a horizontal tangent. Well, what does that tell me? Well, that tells me that the second derivative is going to equal 0 at x equals 0, which means that the second derivative will actually have the point 0, 0 on the graph. Well, what else do I know? Well, the graph of the derivative is decreasing when x is less than 0. So we know that f prime is decreasing when x is less than 0. What does that tell me about the second derivative? Well, it should tell me that the second derivative is negative when x is less than 0. Okay. Notice when x is greater than 0, the first derivative is increasing. So f prime is increasing when x is greater than 0. Well, what does that tell me about the second derivative? It tells me that the second derivative is positive when x is greater than 0. So I know that my second derivative goes through this point, it's negative before I hit that point, and it's positive later. That's going to tell me that I'm going to have a line that goes through this point. Now you might wonder, how steep should I make that line? You could figure that out by doing a test point. See what happens at x equals 1, for instance. If I look at x equals 1 and I draw in a tangent line, I can approximate the slope of that tangent line by saying I'm going to go up 1, 2, and to the right 1. So that's telling me that the slope at 1 is going to equal 2. So that means that the point 1, 2 is on my curve, which puts me right here. I already know I have a line. Let me get a graph of this. It's going to look something like that for my second derivative. Okay, now that I have the second derivative, let's see what I can find out about the graph of the original function f. Well, what do I know? I know that my first derivative is positive for values less than 2. So I know that f prime of x is positive when x is less than -2. That tells me that the original function is increasing when x is less than -2. Now look at what happens between -2 and +2. F prime is negative. It's all below the x-axis. So f prime is negative between -2 and +2, which means that f is decreasing between -2 and +2. Now let's see what happens for values bigger than 2. Take a look at the graph of f prime. It's all above the x-axis. That tells me that since the derivative is positive for values of x greater than 2, the original function f is increasing for values bigger than 2. Not only that, I can see that I have a switch from increasing to decreasing. So right here at -2, I'm moving from positive to negative, which means I'm moving from increasing to decreasing. So I know that f is going to have a relative maximum at -2. Notice my graph is negative and then it changes to positive, which means it was decreasing and then it changes to increasing. So if it's decreasing and then it changes to increasing, I'm going to have a relative minimum. So it has a relative minimum at x equals a positive 2. Now, I can also use the concavity information that I arrived at by getting the second derivative. Take a look at that second derivative. It's all below the x-axis for values less than 0. Because the second derivative is negative when x is less than 0, that tells me that the function is concave down for values of x less than 0. Because the second derivative is positive for values greater than 0, for x greater than 0, I know f is concave up for values of x greater than 0. I also notice that there's a change in concavity right here. So for the original function f, that's going to mean there's an inflection point. So I know that there's an inflection point at x equals 0. All right, so let's take this information and put it on my graph. I know I have some interesting things happening at -2, 0, and +2. At -2, I'm going to have a maximum, so I'll put that right here. This is going to be an inflection point, and I'll also have a minimum at 2. I know my function is increasing concave down, so it's going to look like this. Then it's going to be decreasing concave down. Then it's going to be decreasing concave up, and then increasing concave up. And that is an example of what the graph of f might look like. I hope that was helpful. Thanks.